Hello, my friends. Welcome back. Hope you're all doing well. In the previous video, we talked about the main concepts. I told you what machine learning is, how is that different from artificial intelligence. We talked about the differences between supervised and unsupervised learning and gave you basically all the definitions that you need to know before actually jumping to Python and start learning how to use machine learning. In today's video, I'm going to show you the most popular and common libraries that we will be using in next videos. So stick around to learn what we need to learn and use for machine learning purposes. Okay, the first library that I want to use is NumPy. So we can just go import NumPy as NP. It's very common, as you see in the like everyone's code probably, that they import it as NP. So it's just like shorted and they don't have to type NumPy all the time. NumPy is short for numerical Python. That's a library that is mostly used for dealing with arrays and matrices, right? It has a really good performance. It's a super fast library. And we're gonna use that for, generating data for our machine learning algorithms and see how we can use that in our applications. It is also like a good practice to, like, if you're loading data into your machine learning algorithm, load them into, a NumPy format. Anyway, so let's talk about some basic stuff that we can do. I can go a equals np dot array, like 7. So let's see what happens if I just go print a. It's going to tell me that it's a 7, right? And if I go what's type A, you will see that it says it's a NumPy array, right? But if I say what's type of A, without before converting into NumPy array, it's just going to be an integer, right? But this is not really useful. So let's do something that we actually care about. If I go a equals, this is actually very, very popular and very useful. A range. This is not a range. This is like array range. So it gives you a range, right? If I go like 30 here and then print a, you will see that it's going to print numbers 0 to 29 for me, right? So 0, 1, 2, 3, 4, all the way to 29. So it gives me a range, right? And then I can go, I don't know, like 0 to 30 with, and then like provide it with like, I don't know, let's say 3. That's like the step size. And what's happening now is that it goes from 0 to 30, but like with this step. So 0, 3, 6, 9, 12, like you see each element is calculated by adding 3, which is the step size, to the previous element. This is actually very, very useful. What else can we do? The other thing that we can do is that, let's just keep that back to 30. And what I'm going to do now is that, the reshape function. I'm going to go b equals a dot reshape, right? I can reshape this function. We have 30 elements here from 0 to 29, and I'm going to reshape it to this, and I'm just going to say print b. See what happens now. It says, okay, I reshaped the matrix, or the array that you had was like a 0 to 29 to a 5 by 6 matrix, 1, 2, 3, 4, 5 rows and 6 columns, right? It's smart enough to know that, okay, the first 6 elements go here, the second 6 elements go here, and so on and so forth. Obviously, if I change that to 7, it's going to error out and be like, okay, like the dimension that you provided just doesn't make sense. It says I cannot reshape area of size 30 into shape 5 by 7. It just doesn't make sense. The math doesn't work. And like we can do a lot of cool things. So we saw B, and again go b.shape, that not reshape, shape. I want to see the shape of B. right? I can, like, you can see like a lot of feature, be the number of dimensions. For some reason, it just keep doing that. Print, what else can we see? We can see the size. That's different from dimension. We'll see. Uh, the other cool thing we can see here is print b dot data type. I think it gives you the data type, like what's inside B. So if I print that now, it says, okay, shape is a 5x6, number of dimension is 2, right? Like we have rows and columns, and then B size, that's like the number of elements, that's 30, and data type is int64, the default integer type for Python. Then we can like keep doing a lot of other things. Like I can go C equals a dot reshape, for example. The reshape function is something that we're going to be using a lot. So we have 30 elements. I can go 2 by 3 by 5. So that's obviously like a 3-dimensional matrix. And I'm just going to change this to C so that we can like see everything that we just saw for this new matrix. If I run that, okay, it says the shape is 2 by 3 by 5. Number of dimension is 3, because now we have 3 dimensions, obviously. Number of, like, the size didn't change because we still have like 30 elements and still like 64. And I can honestly just go to show you how C looks like. It's just like print C, and you see it says 2. So we have 2 of 3 by 5. Each of these is like a 3 by 5 matrices, right? So this is that, and like how you can like define different things here. The other thing is that you can go, what else can we do? Oh, we can go np dot, I don't know, like array, and then like just give it a list, right? Like 20 over like 2, 3, 4, 5. And then if I do this, it says, oh, not NO, but NP. Sorry about that. Just clear that, run that again. It says, okay, it's like basically list, but it's an array type now. It's different from a list. As I said, like when you convert a list into a NumPy array, just like the operation is going to be much, much, much faster. You won't see that difference here in this small example, but like when you're dealing with larger amount of data, the difference is actually really obvious. Then you can do something like, what else we can do? We can go ones, 3 by 4. It gives me a matrix of 3 by 4 and fills it with ones, right? NP that ones, oops, I need another set of brackets here. Yeah, so there's the 3 by 4 matrix and like fills it with ones, and you have the same thing for zeros, right? Like if you change that to zeros, you will get same thing, but like filled with obviously zeros instead of ones. That's also very useful for introducing biases and everything for layer. Don't worry about that yet. I'm just going to teach you something that you won't be surprised next time that we're going to use these features as we go ahead. And the other thing we can do with that is that, let's say I go x equals np dot array, and I give it a list like, I don't know, 5, 10, 15, and 20, and then y equals np dot array range of 4, and I'm just gonna go print x, print y, so we know what we expect to see, right? It's just like 2 lists, 5, 10, 15, 20, and 0, 1, 2, 3. Okay, what can we do with this? If I go print, just say some simple operations, x minus y, just does element by element subtraction, 5 minus 0, 5. 10 minus 1, 9. 15 minus 2, 13. 20 minus 3, that's a 17. The other thing that I can do is just if I go multiply, right? It says 5 times 0, it's a 0. 10 times 1, that's a 10. 15 times 2, 30. 20 times 3, that's a 60, right? Cool. If I go add, right, it just does the matrix operation. It's like a math operation and multiply and accumulate. So you remember this. If we add this all together, that's 100. This is what this function is going to give me. If I run that here, it says, okay, that's that. And then the other thing, another cool feature is that if I go z equals x times y, and then if I go print z greater than, okay, let's see. If I go print z, it says 0, 10, 30, 60. If I go print z where it's more than 45, I expect to see false here, false here, false here, and then true here, right? So let's see if that works. False, 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 true. That's awesome. So you can do like a lot of cool things, honestly. Like this is like a lot of, a lot of what NumPy has to offer. It just makes life much easier. If I go, I don't know, like np dot, can just calculate the sine function for z, and he print that, says, okay, this is like sine, can do cosine, and any other function that you want. The other thing that we can do, and it's probably the last thing that I will say about the NumPy, is that we can generate random numbers, right? We can go random dot rand, and then like you can see different function, rand, random, randint, randin. That's like normal distribution. And I say normal gives me a 10 by 50 matrix, for example. And I don't really need these printed statements anymore. If I do this, it gives me matrix 10 by 15. And it's just like everything here is distributed normal, right? Based on a normal distribution. That's basically all you need to know about the NumPy library for now, at least. We can, introduce you other stuff and other things that you can do with NumPy later. But for now, I think it's good. Let's move on now. The other library that I wanted to talk about is the pandas library. Import pandas as PD. Just like the other one, it's very common to short pandas to PD. I have it already installed. If you don't, simply just go pip3 install pandas, right? And just to make sure that I have it installed, and I didn't like yes, so it doesn't complain. Okay, so we talked about NumPy, but what about pandas? What is pandas used for? Pandas is actually like almost the same as NumPy, but it's like much better for large amount of data. So if you're dealing with, let's say, 100,000 data, then NumPy is not really your best choice. You might as well just use pandas. And then also it's like much better for non-numerical data type, because like NumPy is just like numerical Python. Like the name implies that it's meant for numeric values. But pandas, you can have like different data formats in there as well. And also it's like much better for data visualization if we want to plot it later, right? Anyway, that's why we use pandas library. But what can we do with pandas? A very simple example could be that like creating some data. I say pd dot series, right? It basically like gives me something like a list, I would say, but not exactly a list. I'll show you how is that different. So I'm just gonna go like 1, 5, I don't know, 0.2, and then just some random string. Just gonna go Sam, and I don't know, NumPy. We already have NumPy, right? That nan. So nan is like not a number. It's just not a number. Like you define, let's say you divide something by zero, one divided by zero, right? That's not a number. So that's like that. I forgot to mention that when I was talking about NumPy. But anyway, so we have that, and like we can also give it a negative number. And if I go print a, you will see how it looks. So the cool thing about it is that did I run it? Okay, I did that. So the cool thing about it is that like if I make it bigger, you can see it doesn't really give me a list. It automatically gives me like this structure in here. It says, okay, row 0 was 1, row 1 was 5, row 2 was 0.2, row 3 was Sam, row 4 was not a number, and 5 was like -3, right? And data type is like object. Cool. We made something, like we made whatever this format is of, you know, different data types. We can do other stuff, like it can go dates, like in the calendar date equals pd dot date range, and then like you can give it a range. So this time that I'm recording this video is 2023 October, and it's like 23rd of October, and I can say period equals give me 5 days from this, right? And if I print, please, if I print dates, you will see what it gives me. Okay, it's not happy with something. Let's see what's it complaining about. It says name print is not defined. What did I do here? It's just like clear about it. Yeah. Oh, so this is what sometimes my Python goes crazy. I just need to close this and open VS Code again. See, this is not, sometimes it complains about it. Okay, so we're here now again. Dates, and we gave it a date and start day, and say, okay, go 5 days from that. And then if I print that, you will see that history crashed. Okay, no problem, just clear that. It's doing something, and it says, okay, data time index 23rd of October 2023, and then it's going 5 days after that, 24th, 25th, 26th, and the 27th, right? So as I said, it's just not meant only for numeric values, but we have dates here. That's awesome. But what usually pandas library is used for is for data frames, right? Data frames are actually very practical. If I just go like a define a data frame, that's equaled pandas, that data frame. I want to make a data frame, right? I am just going to use what we learned before from NumPy, that random dot rand n, just like a normal distribution, for example. And I'm going to make something like a, I don't know, like a 6x4 matrix, for example. And let's see, print df. Let's see what happens if I do this. If I run this, it makes a data frame for me. See, it kind of looks like a table, which is really neat. It gives it automatic, you know, row names and column names. It says, okay, like these are rows, these are columns. And here you can see like a 4x6 matrix, or sorry, a 6x4 matrix of randomly distributed numbers using like a normal distribution, right? But we can actually make it cool. Like we can say, because, you know, these are the indexes, like I can change the index instead of having Python automatically generating for 0 to 5. I can just go use for index, the dates that we used. This is 6, but we had 5 here, so the size won't match. I have to change that to 6. So if I do that now, we'll get something like this, right? We get the dates that we previously generated as the indexes, and then we get this. The rest is the same. We can, play with that a bit more. We can just go like columns. I don't want to like have 0, 1, 2, 3 because it doesn't make any sense. Just want to go A, B, C. Probably doesn't make that much of a difference, but so for that like how it works. Okay, see, we have the dates in the like for the indexes, and for the columns we have A, B, C, D. Now it's called a data frame, and it's like very useful if we want to use that for our machine learning applications later. So you can obviously do the same things. I can just go print df.data type, right? And if I do that now, it prints the data type, and it says it doesn't, data types, forgot the S. Let's run that again, and it says column A is float 64, column B is float 64, and it gives it for all the columns, which is really nice. We can just say, okay, give me data frame, just the data from column A, for example, right? This is our data frame, and this is the values from column A, which is correct. Like this is what we had. Let me just make it a bit bigger. So this is like what we have for column A, and we just like represented that. Cool. The other thing that we can do, it's really useful for when you have like a huge amount of data and you cannot really print everything here in the terminal. So we can just go df.head, for example, to just show me the first 2 rows of data. If I do that now, you'll see, just gives me the first 2 rows of data, just to quickly verify that like you properly loaded the whatever data that you're working with. You can obviously go tail as well. And let's say tail 1, just like give me the last row of data, right? And it does it. What else can I tell you about the data frames? I can go describe my data frame for me, right? And let's see how it looks like. If I do this, it gives me all this information in here. It says column A has 6 elements in it, so that's column B, C, and D. The mean value is this in each column. Standard error is this. Minimum is that. Maximum is this. These percentages here, like 25, 50, 75, this is basically saying that like 25% of the value that you have in these comments are less than that. 50% are less than that. 75% are less than this value. And basically that is what it represents. You can, like, if you don't need all this information, obviously you can just say, okay, like give me the mean, right? And if I run that now, it says, okay, this is your data frame, and this is the mean values for column A, B, C, and D. Awesome. That's what I wanted to see. Well, you can be specific and be like, it's just give me the, like, for column, I think this was the syntax, like for column B, give me the mean value. And it says, okay, this is like the mean value for column B. That's awesome. And if you're curious, like why like this column B mean is different from this one in here, because it's randomly generating numbers. So every time the numbers are just different. So every time I run this, I get a different value. What else can you do? Like you can just go df.t that like transposes your matrix or your data frame. So here you have like the original one in here, and then like you can see the columns and rows are just like transposed. This is also good. Then you can sort it, like you can go df sort values, like based on values or based on indexes. You can do whatever you want, and it just like sorts it for you. I guess you can just go by equals like put values in column C, for example, right? If I do that, it sorts it for me. We were printing the original one up here, and then the sorted values here, and you can see that it's actually like sorting. You see the column C, the values are sorted from like smallest value to the biggest one in here. And what else can we do here? The other thing that we can do is really cool is that we can go df was just like print the values that are, I don't know, df column D, and if that was greater than 1, then like print those values. So it goes like in the data frame column D. If it was like greater than 1, then it prints it for me. So that's about it. That's probably all we need to talk about for the pandas library. We learned how we can, generate some data, and that's cool. Oh, the other thing that he can do, and it's really nice, and it's like actually very useful. You can just go pd dot. So I was saying that like you can save the files, like read CSV XO. Like if I go read CSV, then like up here you can provide the path to the CSV file. I don't really have a CSV file now, but like you can obviously have a CSV file and just like read the content into data frame. Like if I go here, for example, df equals that, then like you can load the values from CSV file into the data frame and then like start play with that, which is cool. We can obviously like export your values. Like let's say we have this data frame here, you can save it to a file, write it to a file. And I think that was, I forgot, but I think it was right. No. Anyway, we can look it up. That's okay. The other function, the other library that I want to talk about is import. It's a really cool library. It's like for plotting some plots, and we can go matplotlib dot pyplot and as plt. That's again like very, very common, and people usually do that. It's not math, it's matplotlib. That pyplot, that's correct. So this is how we define this, and if I run that just to make sure that I have it installed, yes, it's not complaining about anything, so it's good to go. So this matplotlib library is usually, not usually, it's just used in Python for plotting some values. Let's see. If I go plot plt, or basically that plot, and then if I go value 1, 2, 3, 4, and then I don't know, like 3, 6, 1, 9. So like it plots these values versus these values, and I can just go plt.show me the plot, right? And if I run that now, let's see what I get. It gives me this, so you can see value 1 in the x-axis corresponds to 3, which is like what we have up here, right? Value 2 corresponds to 6. Value 3 is 1, right? It's here. And then 4 corresponds to 9 in here. Awesome. We plotted something, and let's say that we want to say, we want to give it a label, right? We can go plot that for the y label, the y-axis. We could just like give it a label and be like just y label, for example. And if I run that now, you should be able to see that, yes, it's right here. It's the same plot, and it says like a y label here. You can obviously use x label and like title, stuff like that to make it pretty. What else can we do with that? Let's do something cool. If I go here and say, let's do something here. If I go x equals np dot array range from -3 to 3 with step sizes of 0.5. Mm-hmm. So this gives me, as we saw before, like an NP array. We have X, and then I want to go plt.plot X and X. So it's like X versus X, which is like a linear line. And I want to, let's just remove that. And I want to see it in color red, right? See what happens. If I do this, it says, okay, we show you this in color red from -3 to +3 with, you know, those steps. If I go like, I want it in color red, but I don't want it in a solid line. I want it like in a dashed line, right? It shows me this. It shows me dashed line. Okay, cool. So far, so good. But what if I want to do something else? What if I want to go, I want to see X and X squared. Mm-hmm. But I want to see X squared in color blue, and I want to see it in this format, like dash dot, right? If I do this now, it says, okay, in blue, dash dot blue, this is what you see, and like this was the previous one. I say, okay, what if I want to add something else? What if I want to see X and X to the power of 3? Like this time, I want to see it in, I don't know, let's say I want to see it in color green, and then, I don't know, like just a solid line. Let's see what this one looks like. This is like that. This is like X to the power of 3, which is like what we have. Or we can obviously like play with this, like this works. If I go like something like that, let's see what happens. So this is like a triangle symbol. If I run this, it says, oh, I don't know that. Then let's just remove the thingy. And it says, okay, yeah, these are the triangles. Like these are basically the points that you have, which is cool. But let's just go back to the previous one. And I say, okay, now I have like 3 different plots in the same, you know, figure. But I want to like separate them. So I want to add a legend to this. So we can basically just go plot that legend. And here I'm just going to go, the first one was X, right? The second one is X squared. And the third one is X to the power of 3. Let's see how this looks like. Oh, nice. So the legend is here, right? And it says dash red line is X, blue dash dot line is like X squared, and the solid green line is representing X to the power of 3. Cool. So we plotted stuff. The other thing that we can do, and like is actually like really cool, is the scatter plot. That's what we're gonna be using, I don't know, more frequently, I would say, than just like a regular plot. Let's say define data as a dictionary, right? Like we've talked about dictionaries before. So I'm just gonna go, I don't know, throw 1 equals, well, not equals, but like column np dot a range, I don't know, 50 or 20, doesn't matter. Just forget on my end here. This, so that like gives me numbers from 0 to 19, 20 values with step size 1, which is the default value. The second column, I want to have np dot random dot grand int integer values, right? From 0 to 50. And how many of these do I want? I want 50 of those. Awesome, that's good. And then the third row, I want to see NumPy dot random dot land and like a normal distribution of give me 50 values here. So far so good. We defined a dictionary, and now I want to go plot the scatter. It's a scatter plot xy values, right? So give it the x values. The x value I want to give it data row 1, which is just like my x values, right? Well, number 1 to 20. And then for y values, I want to give it data row 2, which is like randomly uniformly distributed integers between 0 to 50. And if I go plot.show here, let's see if we can see anything useful in here. I run this, and it says x and y must be of the same size. Yes, because here we have 20 samples. Here we have like 50 samples. So see 20. Change that to 20 as well. That makes sense. Let's run that again. Okay, as we can see, the random values are uniformly distributed from 0 to 20, right? So this one up here, you can see the x is like, sorry, the y is like almost 18, right? So like if I increase the number, you'll see that it's like randomly distributed. But if I go like for, I don't know, like R3, second though, I expect to see more values because like it's a randomly like normal distribution. I expect to see like values closer to 0 with like a higher population of numbers that are going to be around here, and less numbers other way. Because like our sample size is only 20, it's not really shown very well. Like if I increase that to 200, for example, should be better. So yeah, you see like this is 0 in here. Everything is like focused around this line, and like as we go away from 0 either to the positive or negative direction, we're just going to see less and less samples. I think that's enough for today. I just wanted to talk about these 3 libraries: NumPy, pandas, and matplotlib, and these are the libraries that we'll be using a lot in the next videos. So it was good to go over them before actually getting started with machine learning algorithms. Well, as always, thank you for watching me, and don't forget to subscribe so you won't miss the next videos. Take care. Have a good one. Bye-bye.